When you picture an event with probability 0, what comes to mind? Most people would immediately say, well, if the probability is 0, it's impossible. It can never happen. Surprisingly, mathematics says otherwise. An event can have a probability of 0 and still happen. That sounds like a contradiction. So let's see why. Imagine I'm going to pick one real number between 0 and 1 completely at random. Every single number in that interval is equally likely. What is the probability that I pick exactly 0.5? Your intuition probably says almost 0. Mathematics goes one step further. It says the probability is exactly 0. Wait a minute, if the probability is 0, does that mean I can never pick 0.5? Of course not. If I happen to choose 0.5, then that's exactly what happened. So, how can something with probability 0 still occur? The answer lies in infinity. Between 0 and 1, there are infinitely many real numbers. A single point on a number line has 0 length, or in math terms, measure 0. In a continuous experiment like this, probability is determined by length. Because a single point has 0 length, picking any specific number like 0.5, 1/3, or pi over 4 has a probability of exactly 0. Yet, every time we pick a number, one of those 0 probability outcomes has to happen. It isn't impossible. It's just one hyper-specific outcome among infinitely many possibilities. Now, here's another surprising fact. The numbers between 0 and 1 come in two broad families. Rational numbers such as 1/2 over 1/3. Even though there are infinitely many of them, together they still occupy 0 total length on the number line. Irrational numbers such as the square root of 2 over 2 or pi over 4. These numbers fill essentially the entire interval. As a result, the probability of picking a rational number is 0. The probability of picking an irrational number is 1. Mathematicians say you will pick an irrational number almost surely. Notice something remarkable. Every individual irrational number also has a probability of 0. So even though the collection of irrational numbers has a combined probability of 1, every single number of that collection still has a probability of 0. Here's the critical distinction. Probability 0 does not mean impossible. It just means an event belongs to a set with measure 0. A truly impossible event is outside the experiment entirely. Picking the number 2 when choosing between 0 and 1 can't happen. 2 isn't even in the sample space. Just pause for a moment and think about right now. The exact thoughts in your mind, the words you are hearing, this precise moment has never happened before and never will again. If we try to predict this exact moment in advance using a continuous probability model, its probability would be 0. And yet, here you are living it. Pretty cool, isn't it? Thanks for watching.